Hello everyone, welcome you in my YouTube channel. I am Dr. Mohammad Sirajul. Today in this video I am going to talk about aldehydes, ketones and carboxylic acid. You know, this COH is a functional group of aldehyde, this CO is ketone, this is the carboxylic acid and this is derivative of carboxylic acid. CONH2 is amide, it is also derivative of carboxylic acid. So esters is also derivative of carboxylic acid and acetaldehyde also derivative of carboxylic acid. This is very renowned compound, phenylene, salicylaldehyde and cinnamaldehyde. All contains aldehyde. So nomenclatures, you see common name is acetaldehyde, benzaldehyde, beta-bromo-butyraldehyde. So this is the alpha positions which is adjacent to the functional group carbon. So acetone, acetophenone, propiophenone and benzophenone. This is the common compounds. In IUPAC systems, al is important for aldehydes. You see, always it is in terminal positions. So numbering always they start from here. You see, if it is in cycle, it will become the ketones. So this is aldehyde, this is aldehyde, conjugated aldehyde, and this is your ketones. Here also you see aldehyde and ketone the same. So this is the oxo, 3-oxo, and the main nomenclature will go with the aldehyde pentanal. You see, this is the ketones. So ketone always in between. This is aldehyde. There are many aldehyde group. Then propane. You see 1, 2, 3 propane. 1, 2, 3 tricarbaldehyde. 1, 2, 3 carbaldehyde. And so on. You just take your paper and pencil and start practicing. The structure of carbonyl compound. You see, this is the sigma bond and 1 pi bonds. Pi bond is here. You see, and there is a bond length 120 degree. This is polar in nature, carbon positive charge and oxygen negative charge. Preparation of aldehyde and ketones by oxidation of alcohol, by dehydration of alcohol, or from hydrocarbons, or by hydrations of alkynes. Preparation of aldehyde, you see, this is the from acyl chloride. This is the acid derivative. If it is here OH, then acid. Now OH replaced by Cl, so benzyl chloride. In the presence of hydrogen and palladium barium sulfate, it gives aldehyde. From nitriles and esters, you have the nitrile, tin chloride and HCl, it gives this aldehyde. This is the intermediates. This reaction is known as a Stephen reaction. You see the RCN undergo oxidation, it gives the aldehyde, and this is also CN converted into alkene and CHO. Alkene is already there. From hydrocarbons, oxidation of methyl benzenes, you see this is toluene, undergo oxidations forming this complex, chromium complex, and then this is benzaldehyde. You have the toluene, you see, and benzaldehyde. Side chain chlorinations, you see, if you have this chlorination, the presence of benzyl chloride and then benzaldehyde. Gattermann-Koch reactions, this is benzene in the presence of carbon monoxide and HCl, and hydride AlCl3 copper chloride, it gives the benzaldehyde. This is important reactions, we call it Gattermann-Koch reactions. Preparation of ketone from acyl chloride, this is acyl chloride, dialkyl cadmium, it will give the acetone. You see, this is the, if you have RMGX cadmium chloride, it will give dialkyl cadmium, and then the nitrile react with alkyl magnesium halide forming this intermediate, and after hydrolysis give prophenol. This is the ketones. So what is the physical properties? You see comparisons. This is alcohol, acetone, aldehyde, and methoxyethane, which is an N-butane. You see, alcohol is more molecular mass here 60 and boiling point is more, you see, 370. Why? Due to formation of hydrogen. Acetone also forming hydrogen bond with water. So chemical reactions, you know this double bond have partially negative charge on oxygen and partially positive charge on carbon. So this is the planar. So nucleophile will come from upside or downside both, and they form these addition products. This is the double bond. So nucleophilic addition reactions, showing the nucleophilic addition reaction. You see ACN OH minus, cyanide is nucleophile. Cyanide attack on this carbonyl forming tetrahedral intermediate and then cyanohydrin. Same way disulfide addition compounds. You see, if you have alcohol, again the same way forming hemiacetal and then again react with the 2 OR acetals. If you have the ketone, then ethylene glycol keton. So in this way, if you have the H2NZ, so this remove the water and forming the imine bond, the addition of ammonia and its derivative. So if you have H ammonia, then forming this imine. If you have R substitutions, reagent amine, you substituted amine, then enzymes, then hydazones, then phenylhydrazine, phenylhydrazone. If you have 2-phenylhydrazine, then 2,4-dinitrophenylhydrazones, semi-carbazide, then you will get semi-carbazole. This is very important table for the reaction. Now reductions. Reductions to alcohol, reduction to hydrocarbons, you already know. This is the Wolff-Kishner reductions of CO in presence of amalgam and HCl. You will get this alkane. Now Clemmensen reductions. And CO NH2 hydrazine, this is Wolff-Kishner reduction. Both compound give the alkane, here water removed, here N2 gas. Oxidations. Aldehyde undergo oxidation, give acid. If you have the ketone undergo oxidation, this will break and you see the 2 molecules of acid with different carbon. So if you have the RCHO, this is tolerance reagent, you will get the silver mirror test. Spelling test, if you have aldehyde and copper 5OH, you get red brown precipitate with the Rorschach salt, sodium potassium chloride. You see oxidation of methyl ketones. If you have ketone, you see formations of acid derivative and chloroform or hydroform. In the same way here. Reactions due to alpha hydrogens. What is the meaning of alpha hydrogen? Acidity alpha hydrogen of aldehyde and ketone. This is carbon and this hydrogen. This base trap this hydrogen because this CO and nearby this CO, this carbon is alpha carbon and the present hydrogen is alpha hydrogen. So the formation of conjugation. So very important reaction, aldol condensations. Reactions occur at alpha hydrogen. You see this is the aldol and after removing water forming aldol condensation products. If you have the propanol, it will give this ketone and this is the products. If you have the cross aldol condensations, because this is the CH3 and this is different, so you will get different type of products. Take the copy and pencil and write down the product and try to understand. And other reaction, Cannizzaro reactions, you see this is undergo oxidations and undergo reductions. This will reduce and one is oxidized. You see benzaldehyde and benzyl alcohol and sodium benzoate. Now electrophilic substitution reactions, you see nitrations occurs at these 3 positions, means this is the meta position. So meta nitro benzaldehyde. Carboxylic acid, nomenclature, structure of carboxylic acid, you see the formic acid, acetic acid, propanonic acid, butyric acid, isobutyric acid, oxalic acid, malonic acid, succinic acid, butyric acid, adipic acid, tribialytic acid or carbolic acid, and there is adipic system also. So benzoic acid, phenylacetic acid, phthalic acid. So structure of carboxyl group, you see COOH sometimes what will happen, giving these resonance. Method of preparation of carboxylic acid from alcohols, primary alcohols. You see, this is the formation of acid. This is Jones reagent. This reagent is important for exam. RCO3 H2SO4, dicarbonic acid. From alkyl benzenes, you see, this is CH3 toluene under oxidation to benzoic acid, in the presence of amine. From nitrile and amides, if you have cyanide, then it will go amide and then acid. You see, amide give acid, amide give acid. From Grignard reagents, react with carbon dioxide, you will get the acid. From acyl halide and anhydride, you see acid, formation of acid. Anhydride also give two molecule of acid. Benzoic ethanoic anhydride give the two different products, benzoic and ethanoic anhydride. From esters, hydrolysis to give benzoic acid and alcohol. This is ester, give the butanoic acid and so on. A lot of examples. Now physical properties, you see the formation of dimer hydrogen bond. This is the special properties of carboxylic acid. Hydrogen bond of the RCOOH with water. You see water. Now acidity. This hydrogen is acidic nature, so it replaced by the metal. You see, and base and sodium bicarbonates. It resonance stabilized carboxylate ion. So you see, this is equilibrium constants. So this is the relation between pK is equal to minus log K. So here is the electron withdrawing group concept and electron donating group concept. So friends, effect of substitutions on the acidity of carboxylic acid. You see, this is the carboxylate anion. Electron withdrawing group, EWG means electron withdrawing group, and here EDG means electron donating groups. So electron withdrawing group stabilize the carboxylation anion and strengthen the acid, and this is the weakened acid. So this is very important concept. So effect of following group increasing acidity order is, you see, CF3 is much more than pH. You see CF3 COOH greater than CCl3 and so on. Take the copy in pencil and write it down. Here you see this is resonance stabilized. Here also you see COOH group or CH3 for methoxybenzoic acid. Reaction involving cleavage of COH bonds. So ethanoic acid two molecules forming ethanoic anhydride. This is the mechanisms, the formation of esters. Reactions with PCl5, PCl3 and phenyl chloride will get the acyl halides from acid. Reaction with ammonia, if we have acid, react with ammonia, give ammonium acetate and further reactions give the acetamide. Ammonium benzoate and benzamides, you see phthalic acid, this ammonium phthalates and phthalamides, and this is phthalimide. Reacting involving COOH groups. So reductions direct you will get the alcohols. Decarboxylations RCONA, you will get the alkanes. Halogenations occurs at this CH2, you see halogenation. This reaction is well known, Held-Hard-Zielinski reactions, HVZ reactions. This is important. Ring substitutions, you see metapositions, bromine metaposition. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.